Welcome to the Data Management course. This course was developed for structural engineering students and researchers at the University of Minnesota. You may be wondering why you'd want to take the time to go through the next 6 web-based modules to understand research data management. Well, let's hear from researcher Dave Anderson from the National Climate Data Center on why he thinks this topic is important.
Hi, my name's Dave Anderson, and I'm here to tell you what not to do when you want to archive your data so that it can be preserved and used by others years from now. These are 3 examples of common mistakes that I made in my own research 20 years ago. The first example, here are a couple of files saved in proprietary formats, .wks and an older format from Quattro Pro. Remember those early spreadsheet programs? Try sending these files to a colleague today just to drive them nuts. In contrast, both the ASCII files and the comma-separated value files shown here can be read by any program and will remain readable for many years to come. Another mistake I made is the too short file description, the too short description of what was measured. Here, I succeeded in using the shortest possible designation for a column header, S. It made a lot of sense to me at the time, but I bet you don't know what S is. And here, core 1 has to be the most common core name in the world. If only I had used a little more information to describe what I measured, it wouldn't matter if I got hit by a bus. These data would still be usable. My final mistake to show you is the vague or the pithy file name. Here's a file name I liked at the time called win.dat. After a little bit of effort looking inside this file, I can see that a much more descriptive file name would have been tdf11-taux-july.csv. tdf11 describes the source of the data, tape data family 11. taux describes the variable that was measured, July describes the time period, and CSV describes the format of a file. So there you have it, 3 common mistakes that would not have taken much time to do better and would have made sharing these files 18 years later much easier. It might even have increased my citation rate.
In the next 6 modules, you'll learn how to avoid some of the missteps that Dave Anderson just mentioned, such as file naming conventions, covered in Module 3, and preservation file formats, covered in Module 6. We'll also look at other data management skills, such as how to share your data, ownership issues, as well as potential storage and security measures. After watching each module's video, you'll then be asked to take a moment and write down a strategy for how you will handle your data under various considerations in what researchers call a data management plan, or a DMP. Taking the time to articulate a plan for managing data at the beginning of a research project can pay dividends in the long term. For example, having a plan for how to respond to requests to validate the data will save you time in the future. A plan will also articulate details about your data that will help reduce confusion between yourself and your colleagues who try to access it later. When you're ready to share your data, a data management plan will outline the strategies for release and access control that you will need in order to ethically share it with others. And finally, having a data management plan can be a necessary component of grant requirements from federal funding agencies like the National Science Foundation and the National Institutes of Health. Next, take a minute to return to the course site. Here you can give a short 1-minute reflection paper on how you believe these skills and writing a data management plan will benefit your research data. Then you are ready to move on to Module 2 of the Data Management course.